Maxim.
Hello, 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 hello.
I'm just here for to say hello and thanks for your presentation and session. Thank you
my
so
pleasure.
much. It's nice to see you in our event, and I'm just leaving. Okay.
Good, good, good. So let me share my screen and let's start. Okay. I click share. Let me hide this. Let me turn full screen. Yeah. Hello, 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 dear developers. I hope you see my screen well. I hope you hear me well. And let's chat about background services of our web applications today. First, let's understand what do we have from this set of interesting functionality of the modern browsers, and let's briefly understand how can we use this power or maybe even superpower for good for our dear users, for clients, for customers. My name is Maxim Salnikov. I work in developer relations in Microsoft Norway, and hello from Norway, by the way. I currently organizing PWA Conf, so stay tuned. Maybe this autumn we'll have this. And I'm big fan of the developer communities. I run meetups dedicated to PWAs in Oslo, where I live, and in London. I run a couple of full-scale conferences for web and mobile developers, and I'm Google Dev expert in web technologies. You can reach out to me on my Twitter, WebMaxRU. I mainly tweet about web platform, about progressive web apps, about service worker, and all related APIs. My direct messages are always open, so feel free to ask any questions related to this topic. Let's start. Let's imagine that we as developers, as web developers, as web front-end developers, to be precise, have some interesting possibilities. For example, we can keep our application and data our application consumes always fresh. Cool. That we can build applications which allow our dear users to schedule notifications for any future moment in the time, and we don't have to care about connectivity status during this moment. Awesome. What if we have the tools to somehow work with the bad network conditions when connection status is jumping back and forth, but we still need to make sure that our requests are going to our servers. So it all sounds really interesting, and even more interesting when I mentioned that it's all possible now, even without asking our users to do something explicitly. For example, no longer need to ask people to hit some button to refresh the application or its data. Yeah, it's completely transparent and works automatically. It's all possible in some browsers with the help of background services. So what is background service at all? This is a piece of functionality of the modern browsers which allows us to run our code. And of course it's JavaScript code, right? If we are talking about the browser, run the code with some interesting features or specifics. First, it all runs in a parallel thread to our main one, so it doesn't affect the smoothness and the responsiveness of our UI. That sounds interesting, but you can tell me, we have the same functionality as a part of web workers. Yes, that's true, and this is similarity here, but we have more specifics. This code will have completely separate lifecycle from the lifecycle of our application. And if this code is no longer attached to the fact of tab of the application open or closed, it started by completely different scenarios. And here we are talking about the events. Looking at these 3 points, I have association with phantoms or ghosts. Just imagine that our main application is dead when user clicked close tab button or close browser, but pieces of code of our web app front-end part of it is are still able to start here and there, and they really act like phantoms or ghosts, and then we can think about our browser like house of this ghost. But to be honest, the life of these pieces of code is not that long, but let's explore this a bit later. If we are talking about different events which can wake up these pieces of code, what kind of events are we ever talking about? First, everything related to the network. For example, the fact that we change connection status. So this could be an event sent to our application, or for example, network request was completed successfully or unsuccessfully. It also can invoke the event. Different ways to set up time-based events, and of course we can reach out to these pieces of our apps residing on devices of our users by the signal from our backend. So if we build some form of diagram, of course, in the center of everything there is service worker, which is actually the place where we run this code, which is part of background services. And yes, service worker can receive a variety of events from variety of the sources. First, our application itself can send these events to wake up service worker to run some code there. Then browser, of course, or operating system proxied by the browser. Plus, we can send this event straight from outer world, from our backend, for example. How can we react on these events inside service worker? What are the possibilities here? Lots of. First, we can organize a bi-directional channel of the communication between service worker and our main part of the application. If the application is not running, or maybe even the visible part of the browser is not running, it's absolutely possible to start it from the service worker, to launch the application itself, and again, maybe organize this bi-directional channel. Or maybe we just want to show the notification. And here I'm talking about web push notifications, and I believe you know how that looks. This is a native part of the browser, so it's not something that we create in UI of the application. No, it's part of the browser, or maybe on some operating systems, this is part of operating system itself. So for example, on Windows, you can set these notifications as a part of notifications center. Or maybe without launching the application, without showing any kind of notification, we just want to run completely custom code. Just, for example, to refresh the application or its data. So the next time it starts, users will see next version and, for example, a fresh feed of tweets or news. And we can do it completely invisible for the customer. So this is where the real power and let's say some interesting features are. Good. Let's go back to the background services themselves. What do we have in the current versions of Chromium-based browsers? It's super easy to understand. What do we have? Just open DevTools, go to Application tab, and in the bottom left part of this, you will see list like this. And of course, this piece of DevTools is not to just list this background services we have, but to help us developers to debug, to test this if needed. I believe it started from Chromium version 80, where we have the possibility to go through these events our service worker receives and even record them, which simplifies our life as developers a lot. Because let's say it's quite challenging to understand what's going on under the hood of the application of the browser. Now we have this great possibility. Let's briefly go through some of these services, and we'll discuss in a bit more details couple of them. So first, payment handler. This is quite unique one in terms of you can get your service worker installed just in time, on the fly. And I believe it's the only API which allows us to do this. It's here to help to build web-based payment systems. So it's quite a niche use case when your company needs to build a payment service completely based on web technologies. So we can skip this for now, just because it's very niche. Background sync is our main helper in one particular thing. When we want to wake up our service worker on the fact when user goes from offline state to online. What do we do later based on this signal? It's completely up to us. The main use case here is to repeat the failed request done by user while they were offline. So this way we can, for example, make sure that we propagate to our backends all the data user tried to send to the network while they were offline. Background fetch is two hands. On the one hand, it's to detach. It's to detach download process from the application lifespan. So this is main difference from, let's say, regular fetch. So when user closes the application tab or visible part of the browser, we can make sure that download we started, for example, I don't know, some big file or audio file or maybe video file, this download process will continue and users will have full control because it has its own UI. On the other hand, it's to attach the data we downloaded or uploaded using this API to the application, not to the operating system. Just to elaborate a bit, when you download the video file using regular Anchor link, it works good, and you have the same UI showing the process, and you have the possibility to cancel this or postpone this. But the file you downloaded becomes part of operating system, right? It's somewhere in your downloads folder, and your web front-end part of the application has nothing to do with this. We lost control. With this API, we can get these bytes downloaded by background fetch and put it, for example, into cache storage to use it later inside our application. This way, we can build purely web front-end driven, for example, podcast application, which allow you to pre-download some episodes. This is maybe the most obvious scenario. Push notifications, push messaging. Here I want to remind that in this API, we can actually run any custom code in addition to showing the notification, but the limitation here is we have to show this notification, right? So we cannot do anything without notifying user that at least something happened. So we can spend this like seconds we have in service worker to run the code for something, for example, fetch fresh data, but the users will see that something is going on. What's left? Periodic background sync and notifications. They are similar in one particular moment. They are sorry, let's do a step back. Notifications API is a big helper of push messaging, and in the big picture, push API doesn't make any sense without notification, right? They always work in pair. But notifications API is self-standing one, so you can use this for showing anything based on different scenarios, not only on push. And we'll continue our discussion in the key of notification triggers API. Both notification triggers and periodic background sync are somehow time-based activities. So your service worker will receive event based on timing. Maybe this is only thing that unifies this API, and lots of differences. And actually, let's explore this API by their differences. So I found out that it's the simplest way to jump into what this can do. Timing. Even from the name of periodic background sync, we understand that it's something based on intervals, right? So some periodicity. While notification triggers is the API where we set particular timestamp when we want to show our notification. What can we do by the signal arriving to our service worker based on this? In periodic background sync, or let's call it PBS, just to save some time, we can run completely custom code. Literally, in the service worker, we receive this event, we do whatever we want there. While notification triggers, we can only show the notification. And in the big picture, we don't need service worker at all here. Visibility-wise, PBS completely transparent. I mean, our users will not notice anything that something happened if we want. So notification triggers, even from its name, yes, it's nature to show the notification. So let's look at these 3 points for PBS. First, once it's registered, it will run forever. Let's say until we or user deregister this or like reinstall the browser completely. We can run any custom code inside service worker, and we can do all this without notifying user. So that brings lots of possibility to, let's say, misuse this API or use it for something bad. This is why the final decision on periodicity and to run this API at all or not is on the browser side. This is why I said user agent in decision maker, while we don't have this limitation in notification triggers API. Connectivity wise, the power of notification triggers is it can work offline, literally. We can easily build completely web front-end based alarm clocks using this this functionality, because we don't care about connection status. While PBS only makes sense while users are online. Furthermore, there is one more limitation. Event from PBS will come to the service worker only on the same network where it was registered. It's part of specification, and it's to keep users' privacy. And more prerequisites required in PBS case. First, explicit permission, and it only works for installed web applications. Luckily, thanks to Web App Manifest specification, we know how that works, and more users understand that modern web applications, which are progressive web apps, can be installed on user's device, can be part of desktop on desktop systems or part of home screen on mobile devices. So it acts and works like a native application, right? For notification triggers API, we need to ask user for this quite generic notification permissions, which is the same, for example, for web push or for any other notification you want to show. Okay, time to look at some code. Let's give a super brief dive into how that might look. PBS all starts with registering of this synchronization. And I believe in most cases it happens in the main thread of your application. This is why I call this imaginary file main.js. And please have a look. I always start with the feature detection because this API, you see, it has lots of limitations. It's implemented far not in every browser yet. So that really makes sense to understand, can we ever use this API here and now, just to make sure that the core functionality of our application will continue working without breaking anything and without pushing too many red lines in the console log. So if this API is here in the registration of the service worker, we can set interval. And here we are reasoning about minimal interval. Let's say we are asking the browser, please send this signal or event to the service worker not more often than. In my case, this is 1 day. And in the service worker part, we listen to event called periodic sync. Inside, we can do whatever we want, as I already mentioned. But even with all these limitations and considerations this API has, we can do step forward, and we can show even more care about the user. And here, this is why I have this comment here, sync before you sync, because we can, in addition, check if the user on Wi-Fi or cellular connection. Maybe if we want to, let's say, download some bulky resource, maybe we can postpone this if it's not Wi-Fi. Or even more, if user in data saver mode, maybe we can again skip this download for now. After all, if we download something, we want to check if there is enough space on user device. So these are not obligatory checks, but please, let's be careful with our users, and let's use this API for good, because it easily can happen if let's say many developers start to misuse this or that part of web APIs. Browser vendors, based on the feedback from the users, they add, let's say, extra checks, extra complexity, extra borders to start using this API. Like, for example, it happened with web push API. So now it's stricter and stricter and stricter, and it's not because browser vendors like want this themselves, right? It's all based on the feedback from the user. So to sum up, please make sure that you really want to run some code in this event. When we are talking about time, is it like minutes or days or whatever? Because you remember that it's browser decides this periodicity, and I can say that it's hours. So in the best case scenario, we will receive this event in our service worker every 12 hours. And this is part of specification. I mean, not exact timings, but this, let's say, this kind of duration. So it's not about every second or even every minute synchronization. No, it's something to keep our application fresh and its data fresh without consuming too much resources, because every time this API runs, you remember, it can run without any user notification, it can run without application tab open, it can run without visible part of the browser open. Every time it runs, it consumes CPU, memory, network, and this is sort of protection of our users from overusing of their resources. And so you see, the timing is flexible. What does it depend on? It depends on a synthetic index called engagement score. And in the big picture, this is popularity of your application for this particular user on this particular device. If the user is opening this app quite often and spend lots of time in it, for example, like I do in mobile Twitter, then you will get this 12 hours. If your application was installed and forgotten, maybe this API will just stop working. Notification triggers. Another interesting time-based API, a part of background services, starts pretty much similar from the feature detection. Again, this is not obligatory part, but this is best practice. This is just a good manner on the web with all the APIs related to PWA. So, okay, if we have this API available, we can set particular timestamp. So in this example, this is 5 seconds from this particular moment when we want to show this notification. And basically, we use same method called show notification, like we have in push, but it goes from the registration of the service worker, right? And it's interesting that for the simplest scenario of this API, we can skip service worker part of this completely. I mean, we will not have any code in the service worker, because after all, this is just to show the notification. But at the same time, we need the service worker to be registered and ready and active, because of course the service, the background service part of your application can run only inside service worker, right? So, here you see a simple demo of how this notification might look on Windows 10 application or operating system, sorry. Next example is when I decided to somehow mimic behavior of periodic background sync using notification triggers API. And this is where we also can involve service worker part of the application. So it starts similar, right? We check the availability of this API in the browser, and we call the same method called show notification. Here we also can pass a tag just to name this notification somehow, because yeah, we can have multiple both periodic background syncs and notifications, and maybe we want to do different actions based on this or that. This is why we can specify tag to somehow differentiate. And here we can, as I mentioned, involve service worker. And in the service worker part, we have same events, absolutely the same ones like we had, for example, for web push: notification click and notification close. So what happens? We scheduled this notification for 1 day starting from this moment, and this notification will show up again, regardless of connection status, regardless of if your user has your application tab open or browser open. So this notification will pop up, and here in this notification, we can ask user, for example, do you want to refresh contents of your application? For example, if we created web-based Twitter client, we can ask, do you want to keep your feed fresh? And if user click yes, we receive this event called notification click in our service worker, and here we can update the content, or maybe update the content and launch the application itself, like in my example. Again, it's completely up to us. Of course, maybe this is not the main scenario for notification triggers, ask for updates, but it's somehow mimic PBS with the one core difference. It requires explicit interaction from the user side. Good. What's available from these APIs in different browsers today? I have long answer for you. It depends. Depends on many factors. Like, is it desktop or mobile? Is it Windows or Mac or Linux or something else? It depends on is it Chrome or Edge or Firefox or Safari or something else, and on particular version. Plus, for example, when we are talking about background services, it really depends if the user has the setting to keep browser running when they close its visible part. I believe it's turned on by default, but still user can change this setting. Plus, maybe some of these features are under the flags now. Plus, some of these features might be in origin trial, so it depends on particular host. If you remember, for periodic background sync, it depends if the application installed or not. It only works for installed ones. Lots of factors. You can check particular availability on these resources I listed. But of course, if I have long answer, I have short answer for you, right? And short answer is, let's remember what P in PWA acronym means. And it means progressive. And it's very specific definition of progressive here, means progressive enhancement. Let's don't forget to use feature detection, and let's not think about these APIs like about something core part of functionality of our app. Let's say we cannot rely on them, right? We can improve our application by this, but in the big picture, we always have to think about some form of fallbacks, or maybe notifications that it's not available, or maybe not showing these pieces of UI at all if it's not available. Time to sum up. The goal of APIs which are part of background services family, and maybe majority of PWA APIs, is to catch up and maybe overtake what native code can do. And we are quite close to this. And in some APIs, for example, this periodic background sync, it's even more flexible compared to APIs exposed by, for example, I don't know, iOS for iPhones and Android. User experience-wise, we have to find the balance. Both we as developers and folks who work on the specifications and the standards, because every feature of the ones I mentioned is demanding something from the users. It could be one more annoying permission request. It could be some privacy and security considerations. It could be some extra resources needed to run your application. So finding the balance is very, very important. Developer experience-wise, I think we are at a very good time point when we have specifications in more or less well-shaped form. Plus, we have this tooling, as I mentioned, in developer tools, which simplifies our life a lot. And what I love the most, this is just the beginning of a great journey of PWAs and all APIs related to web capabilities and installabilities. And you can follow the progress on Fugu API tracker, which is public, which is, again, great friendly step for developer community from the creators of Chromium. To continue the discussion about background services and everything related to PWA, I invite you all to join PWA Slack. It's open Slack team with thousands of developers. And thank you very much. I'm ready to answer your questions. Let me stop sharing my screen. And basically, I'll try to open YouTube live. Okay, let me jump in here and stop sharing.
Hello again.
Okay,
I think there is no question.
No questions. That's good. That means that I explained everything so well.
Yeah, that was awesome session.
Good. Anyway, folks, feel free to reach out me on Twitter, webmaxru. I'm super happy to answer your questions, and yeah, let's chat about PWAs and everything related to this. And thanks to Enes and all organizers for having me. It's great pleasure to present for GDG Bursa.
Also for us, thank you for everything again, and ciao.
Bye bye.
See you.